So after having a look at how to calculate the PMCC value and what it actually stands for, we're now going to have a look at hypothesis testing with PMCC. Now we do a lot of hypothesis testing in A-level statistics, and in real life they do come up quite a lot, especially if you do a science-based subject. Hypothesis tests are used to show that we have actually found some evidence of something. So we can use PMCC to do a hypothesis test to determine if there is a link between two variables when we have a sample of bivariate data. This is done to decide whether there is enough evidence to suggest a correlation between the two variables, which is when we reject H0, and not enough evidence, which is when we accept H0. So our H0, or what we call null hypothesis, is going to be saying that we haven't found any difference. And our reject H0 is going to be saying that we have found a positive, negative, or some kind of correlation. So the critical values for this test are found in your formula booklet. This is on page 23. And if the hypothesis test doesn't tell us a significance level to use, then we're going to use a 5% significance level. Now, most hypothesis tests in A-level statistics are split into two different types, which are one-tailed and two-tailed. So we're going to start off by having a look at the one-tailed hypothesis tests. So in PMCC, the one-tailed hypothesis tests are looking for either a positive or a negative correlation. And usually it will say the words positive or negative in the question. However, sometimes it could just describe the correlation. So as one variable increases, the other variable increases, or as one variable increases, the other variable decreases. That suggests a positive or negative correlation, respectively. So you need to be careful. If you don't see any keywords, you need to be reading it carefully to decide what kind of situation it's trying to describe. So you need to count the number of pieces of data that we have, and that means sets of data. And we need to check for the significance level. Remember, if it doesn't say the significance level, we're going to use 5%. And we're going to use this to look up our critical value. You can see here I've added a little snippet from page 23 of what the critical value table looks like. Along the top you can see that it's got both the one-tailed and the two-tailed. For this part here we're only looking at one-tailed, so I've put a little box around that. And you can see that we've got the significance levels in percentages across the top, and down the side we have the number of sets of data that we have. And as we were just talking about a null and alternate hypothesis, our null hypothesis, remember, which is H0, that's always going to be rho, which is this slanty P symbol here, equals 0, and that's for both one-tailed and two-tailed. But for one-tailed, our alternate hypothesis, which is our H1, is going to be that rho is greater than 0 or rho is less than 0, depending on if we want a positive or a negative correlation. And remember, when we were talking about what PMCC actually is, we were talking about the fact that it varies between 1 and -1, with 1 being perfect positive correlation and -1 being perfect negative correlation. So if rho is greater than 0, then we're suggesting that it is a positive correlation, and if rho is less than 0, it suggests a negative correlation. The reason why you need to make sure it's definitely a rho symbol and not a P symbol is that that stands for a different hypothesis test that we're going to use later on. So, our first example, we have a group of antique collectors who are invited to estimate the price to be made at auction of 8 different items. Their estimates, along with those achieved at auction, are presented in the table below. So you can see here we've got the estimated price for each item and then the actual price that each item went for. And we're investigating at a 5% significance level whether there is positive correlation between the estimated and the actual price. So, as I just said, our H0, our null hypothesis, is going to be saying that there's no correlation, so rho equals 0. And our H1, because we're looking at positive correlation, so if we had a positive R value, we'd be expecting it to be greater than 0. So then we actually have to calculate what our R value is. So remember, just as we did before, we need to type the data into our calculator. So I've just paused the video for a second and I've just typed in all that data into my calculator. I typed in the estimated price into list 1 and I typed in the actual price into list 2 in the same manner as we did for the examples in how to just calculate PMCC. So remember, then in the calculator we have to go to calc. We're looking at regression, so we have to go into reg. We're talking about linear regression, straight lines, and the variable that's in the straight line graphs is an x, so we go to x. And then remember that we're going to be using a plus bx later on, so we're going to go into that now just to make it so it's consistent. And there's our R value, so we get 0.967. So that's quite a high R value. We would be expecting to find that that gives us a positive correlation. Now this value here that I've just written down, because I'm now doing a hypothesis test with it, this also gets a special name, and that special name is called the test statistic. And most hypothesis tests that you do, you're finding a test statistic, you're comparing it to a critical value, and that tells you if you are accepting or rejecting your H0, whether you're saying that there is no change or whether you're saying that you have actually found something. We do shorten this down. We shorten it down to T.S. And you don't need to define what that means. The examiner will know that TS means test statistic. So our test statistic is 0.967. Then we need to have a look at our critical value from our critical value table. So if we have a look here, we have 8 pieces of data. It tells us here, but also 1, 2, 3, 4, 5, 6, 7, 8. Got 8 different items that we were looking at. One-tailed, because it says positive correlation, and 5%. So where it says one-tailed, we're going to go across to 5%, and then we're going to go down to 8 pieces of data. So we can see there that that's 0.6215. Now it's very important that your test statistic and critical value, so remember that this is critical value again, we shorten that to CV. You don't have to write down the full name. I've just popped that there to remind you. You need to make sure that they're clearly labelled because we're going to make a conclusion drawn on these 2 values. So it needs to clearly say CV equals something, critical value equals something, and TS, test statistic, equals something, because that's what we're going to compare. So in this case, we can see that our correlation is stronger than what we needed it to be. We needed the value to be above 0.6215, and it is. We got 0.967. So that means that we have found a positive correlation. So as our test statistic is bigger than the critical value, we have found something. So remember, that means that we say that we reject H0. We found a positive correlation. We have to state at what significance level we did this. So we did at a 5% significance level. There is, and we have to be careful because in statistics, we never find something for certain. We only find something that suggests. So we say that there is sufficient evidence to suggest a positive correlation, and then we have to add in the context from the question. So it was between the estimated and actual price of the antiques. So now we're going to try another example. So here we have 12 carrots. So each one of these is representing a carrot. On sale at a market stall. X is representing the length of the carrot and Y is representing the maximum diameter of the caret. And we can see that we've got the results here. And we're trying to use a 5% significance level to determine if there is a negative correlation between the length and maximum diameters of the carets. So this time our H0 is still rho equals 0, no correlation. And remember, for PMCC, the H0 will always be rho equals 0. Our H1, because we're looking for a negative correlation this time, is going to be rho is less than 0. And just as we did before, we need to go back, delete what's in our calculator, and type our new values into the calculator, the lengths going into list 1 and the maximum diameter going into list 2. So now I've typed in my values into my calculator. I go to calc, reg, x, a plus bx. And remember, it's the r value that we write down, and this time it's minus 0.208 to 3 significant figures. Now you need to be careful because sometimes in some of the functions on the calculators the minus signs are quite small. Always make sure that you double check to see if you have got a negative sign. So just as we did last time, this is our test statistic. However, when I look at my critical value from my critical value table, that is going to give me a positive number. And because I always want to be comparing a positive number with a positive number because it makes it a lot easier to make the comparison, I want to make it so that my test statistic is positive. I do this by using what are called modulus lines. Now what the modulus lines look like is that it's just two straight down lines that go either side of the words test statistic. And what that means is that we're just looking at the size of the test statistic, not the sign of the test statistic. So instead of minus 0.208, we'll just have 0.208. And that makes my comparison later on much simpler. So this time the critical value, you are actually going to have to get your formula booklet out. Remember page 23. It's one-tailed because it says negative. It's 5%. We have 12 pieces of data, we're told there, and you can also count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that ends up giving me 0.4973. So we can see this time that our correlation, our size of the test statistic, is not as big as our critical value. So we don't have a strong enough correlation to suggest that we have a negative correlation. So this time, as our test statistic, and remember it's the size of the test statistic, so you need to put the lines either side of it, the modulus lines, is less than the critical value, this time we're going to accept H0. Now it's very important the way that we write the conclusion, so please pay attention carefully. We still state what significance level we use, so at a 5% significance level, there is, and this time we say insufficient evidence to suggest, and we still write about what our H1 means. So to suggest a negative correlation. And we don't say X and Y, which it says in the table. We say what X and Y stands for. So between the length and maximum diameter of the carets. So I just want to point out the differences between when we accept H0 and when we reject H0. Firstly, for PMCC, as long as you make it so that both of your comparisons are positive, if your test statistic is greater than your critical value, you will reject H0. If your test statistic or the size of your test statistic is less than your critical value, then you will accept H0. You still have to state what significance level you used. However, if you are accepting H0, you say that there is insufficient evidence. If you're rejecting H0, you say that there is sufficient evidence. And then the rest of it is the same. You say what kind of correlation you were looking for and then what the two variables were. So now I would like you to pause the video and I would like you to give the Now You Try a go. So hopefully you paused the video and gave the Now You Try question a go. You can see here we've got H0 rho equals 0 again. H1, because we're looking for a positive correlation, rho is greater than 0. Putting the values into our calculator and rounding it to 3 significant figures gets us an R value of 0.481, which is our test statistic. Critical value from the critical value booklet on page 23 gets us 0.4973. So this time again our test statistic is smaller than the critical value, which means that we accept H0 at 5% significance level. There is insufficient evidence to suggest a positive correlation between the mean rainfall and sunshine per day. Now, the reason why, and I just want to clarify this here, we still talk about our H1 is that we weren't testing to see if there was no correlation. And we cannot say that we have proved something that we haven't tested. And we never test for nothing. The whole reason why we perform a hypothesis test is to see if it has changed or hasn't changed or has increased or decreased or didn't. So we never ever say, well, in our conclusion, we never write about our H0. We always write in reference to our H1, whether we had sufficient evidence to prove it or to suggest it, or we had insufficient evidence to suggest it. So now I'd like you to pause the video again and give the second Now You Try question a go. So this time we were looking for a negative correlation. So we have less than 0. Putting those values into our calculator, we end up with minus 0.773 to 3 significant figures. Remember, because it's negative, we need to have a look at the size of the test statistic. The critical value, be careful this time because we have a 10% significance level instead of the other ones where it was a 5%, which gives us a critical value of 0.5067. So this time the size of the test statistic is bigger than the critical value, which means that we have found something, so we reject H0. At 10% significance level, there is sufficient evidence to suggest negative correlation between population density and distance from town centre of the suburbs. So as I said before, the ones that we've just looked at now are what we call a one-tail test. We are now going to go on to having a look at what a two-tail test looks like. As I said, most tests do have a one-tail and a two-tail version. So in a two-tail test, we then, when we're looking up our critical value, we'll use the bottom line to have a look at the significance level that we're asked to use, but we still go down the number of sets of data that we have. So there are two words that they tend to ask, say that we're looking for a correlation or an association in the question. And again, we need to count the number of pieces of data. Our null hypothesis, our H0, is still going to be rho equals 0, but this time our alternate hypothesis is just going to be rho is not equal to 0. And that's shown by this equal sign with the line through it. Now, the reason for that is that we're not looking for a certain direction. We're not looking for a positive or a negative correlation. We are just looking for a correlation or an association. So that means that we can't specify a direction. We just know that it won't be 0, so not equal to 0. So in our example, we have the results showing the yield for given input of a chemical experiment corresponding to the input are shown in the table. So we can see here the input in grams and then the yield that gives. And we're asked to test at a 5% significance level whether there is an association between the input and the yield. So you can see there's no positive, there's no negative, there's no description of as one increases, the other increases or decreases. So it just says an association. So that means that our H0 is still going to be rho equals 0. And this time our H1 is going to be rho is not equal to 0. So then again in our calculator we need to go back, delete what we already have in there, and input this new data into the calculator, putting your input into list 1 and your yield into list 2. So you can see there I've just typed all my values into my calculator and double checked them. If you've gone all the way back, remember it's calc reg x then a plus bx. And this time our R value comes out as 0.484 to 3 significant figures. This time, using our critical values table to look up our value for the critical value. Remember that this is our test statistic, 0.484. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs of data. So along the top, remember that we're going across from 2-tail this time to 5. And then we're going down to 10 pieces of data down the side, which should give you a critical value of 0.6319. And again, our conclusion is based the same way as it was for our one-tail test. So as we don't have a strong enough correlation, so the test statistic is smaller than the critical value, that means that we haven't found a correlation, so we accept H0. Again, state what significance level we used. So at a 5% significance level, there is, and we still say insufficient when we accept and sufficient when we reject, evidence to suggest, and remember what I was saying before, that still counts, it counts for all hypothesis tests. We're writing about our H1, so to suggest an association or a correlation between input and yield from the experiment. If we would have ended up with a negative R value, we would have done the same as what we did before, which is to have a look at the modulus, the size of the test statistic, not just the test statistic, so that we can make a similar comparison. I'd now like you to pause the video and give the Now You Try a Go. So hopefully you've paused the video and given the Now You Try a Go. Again, we're looking for a correlation, which tells us that it's a 2-tail test. So our H0 is rho equals 0, our H1 is rho is not equal to 0. Putting those values into our calculator, we get an R value of 0.658 to 3 significant figures, which is our test statistic. Using the critical value table, bearing in mind that it's 2-tail, 10%, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sets of data, we get a critical value of 0.5494, which means that as the test statistic this time is bigger than the critical value, we found a stronger correlation, which means that, yeah, we found one. We reject H0 at a 10% significance level. There is sufficient evidence this time to suggest a correlation between Judge X and Judge Y scores in the beauty contest. Thank you very much for listening.